So I will hit the reset button and you can see this run through. So it initializes both CAN buses, makes sure that they're working correctly, and then it begins to both send and receive and interpret the data. And so during the setup, this is the first CAN A initialization, and if it's good, it says CAN bus A initialization OK. It delays for a second, clears the screen, delays another second, then initializes CAN shield B. Same thing, gives you a message if it's all good. Then it displays some of the static values on the screen. And I call out a table here for the actual CAN bus message. And I started off just with full of zeros because there's nothing to send yet. So then in the loop, this is where I pull in the X RPM and the Y load values and scale them to 8250 RPM and 1000, which essentially is 100%. I go through my bilinear interpolation as I did before to get a result, and that result is the eBooster RPM. Then I have to play with some bit shifting because the eBooster wants a 10-bit eBooster RPM command in the CAN bus message. So I got to shift some things around, and then because I'm only sending 8-bit values through the CAN bus shields, I have to assign a low byte and a high byte. So essentially there are 2 bytes that will total the 10-bit eBooster command and a 6-bit string of zeros. So then here's where, so that's generated the signal, and here's where I'm actually telling it to send that signal through from the buffer. And following the sending of the signal, I then assign a new buffer, or a different buffer, length 8, and I check to see if there's anything coming in on the CAN bus, and if there is, it prints out, or I should say it assigns the CAN ID, which is the message ID, to a variable, and then assigns the values to the buffer itself. And here's the printing. So it first prints the RPM values on the screen, which is the top left. Then it prints the load values on the screen. Then it prints the eBooster RPM. So that 3000 RPM is the command that should be sent out on the CAN bus network or message. And then this final strip here is just printing the actual buffer along with the CAN bus ID. Oh, sorry, CAN bus ID gets printed up here. No, here it is. CAN bus ID gets printed here, so that's the message ID. And then after that, at the very bottom row of the screen is the actual message. And so you can see here, there are 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I ran out of space. So there's actually, it's a string of 8, and it just runs off the screen here. But on the eBooster, the first 2 bytes are 0. The third byte is a 10-bit RPM command, which in this case takes up both of these bytes. And then the subsequents are zeros. There are a couple out here that can be used for other things, but I'm currently not. So as you see, when let's go to some load and RPM. So as you see, eBooster will come on about 1500 to 2000 RPM, 2000, 2500, 3000. It is full bore. So you see the CAN bus message is changing as the RPM changes. And so again, the top right is what should be sent out on the CAN bus, and the bottom row is actually the message that is being sent from the upper CAN bus shield and being received by the lower CAN bus shield, and the Arduino is interpreting all of that. So this represents the setup. This top one represents the setup that I'll have in the car to send messages to the e-boosters. The second CAN bus here is acting as an e-booster currently, but it will be used to drive the second e-booster because the two e-boosters cannot be on the same CAN bus network. They have the same address. So I'll have to have two separate CAN networks, and they'll just be sending out this exact same messages to both e-boosters. Took me a while to get here, and all of the documentation on these Seed Studio shields is pretty crappy. So it took me a lot of experimentation to figure out exactly how to make all this happen. So that's where I'm at. Pretty happy with where I'm at.